In this video, we will discuss reduction formulas for reducing the power on trig functions and the half-angle formulas for sine, cosine, and tangent. That is, we'll discuss and illustrate formulas for sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. We'll start with the reduction formulas as they derive directly from the double angle formulas. We will state and prove each formula and then consider specific problems in which the formulas are used. First, we have that sine squared theta is the quantity 1 minus cosine 2 theta over 2. Next, we have that cosine squared theta is the quantity 1 plus cosine 2 theta over 2. Finally, we have that tangent squared theta is the ratio of 1 minus cosine 2 theta to 1 plus cosine 2 theta. The proof of this third identity is almost obvious from considering the ratio of the first two. The proofs of these formulas result from straightforward application of the double angle formulas for cosine. First, we'll prove that sine squared theta is the quantity 1 minus cosine 2 theta over 2. We start with the identity for cosine 2 theta of 1 minus 2 sine squared theta and solve for sine squared theta. We add 2 sine squared theta and subtract cosine 2 theta from both sides of the equation and then divide by 2. Similarly, we prove cosine squared theta is 1 plus cosine 2 theta over 2. This time we start with the identity cosine 2 theta equals 2 cosine squared theta minus 1. Then we add 1 to both sides and divide by 2. Finally, let's prove the third identity, that tangent squared theta is the ratio of 1 minus cosine 2 theta to 1 plus cosine 2 theta. We start by using the fact that tangent is the ratio of sine to cosine. Then we substitute the previous two identities and simply divide fractions by multiplying by the reciprocal of the divisor. And then we cancel the 2 to simplify the fractions. Let's look at one example using the reduction formulas before moving to the half-angle formulas. Reduce cosine to the fourth theta to an equivalent expression that does not contain powers of trig functions greater than 1. This problem is similar to verification of an identity, but we don't know what expression we're working towards. Let's start with the fact that the fourth power is the square of the second power. Then we can reduce cosine squared theta to the quantity 1 plus cosine 2 theta over 2 and square this. Remember that to square a binomial, we expand or FOIL in the numerator 1 plus cosine 2 theta times 1 plus cosine 2 theta, which produces a middle term. Notice that we now have another cosine squared term that we can eliminate. We can use the reduction formula again and substitute cosine squared 2 theta as 1 plus cosine 2 times 2 theta over 2. We've also separated the expression into the sum of 3 separate fractions. Next, we distribute the 1/4 in the last term, and finally we collect like terms. 1/4 plus 1/8 is 3/8. Now we have an expression equivalent to cosine to the fourth in which the powers on the trig functions do not exceed 1. Now let's switch to consideration of the half-angle formulas. First, we have that sine of theta over 2 is plus or minus the square root of the quantity 1 minus cosine theta over 2. The plus or minus depends on the quadrant in which the angle theta over 2 lies. Next, cosine of theta over 2 is plus or minus square root of the quantity 1 plus cosine theta over 2. Again, the plus or minus depends on the quadrant in which the angle theta over 2 lies. Finally, tangent of theta over 2 can be expressed as either 1 plus cosine theta over sine theta or sine theta over the quantity 1 plus cosine theta. To reiterate, in the first two formulas, we must choose plus or minus as appropriate to the quadrant of the angle theta over 2. This time, we will present only one proof and leave the other two to the viewer to work out. We will prove that cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. From the reduction formulas, we know that cosine squared theta equals 1 plus cosine 2 theta over 2. Thus, taking the square root of both sides, we get that cosine theta is plus or minus the square root of the quantity 1 plus cosine 2 theta over 2. If we make the substitution u equal 2 theta, then theta would be u over 2, and we have the half angle formula as we recognize. A variable change would make the formula look exactly as stated. Let's consider an example to illustrate use of the half angle formulas. Evaluate cosine of 7 pi over 8. We might try to rewrite 7 pi over 8 as a sum or difference of special value angles, but after trying, this appears unworkable. Let's itemize what we know. First, we know that 7 pi over 8 is a quadrant 2 angle. Thus, cosine of 7 pi over 8 will be negative. Also, 7 pi over 8 is half of theta equal 7 pi over 4. Therefore, we can use the half angle formula, plug in theta equals 7 pi over 4, and evaluate cosine of 7 pi over 4 as root 2 over 2, and the rest is algebraic simplification. We multiply the radicand by 2 over 2 to eliminate the fraction in the numerator. Then we distribute the 2 in the numerator. And finally, we take the square root of both the numerator and the denominator. We get that cosine of 7 pi over 8 is negative square root of 2 plus root 2 all over 2. This is an exact simplified answer. An approximate answer could be given by cosine of 7 pi over 8 is approximately negative 0.92388.